Good afternoon. Indeed, I'm going to speak about arithmetic, but perhaps, some clarification is needed in the beginning. So to address at least part of the theme of the conference, digitality or digital reality, one can think of it as being deep down about binary arithmetic, but perhaps this is too dry, and I would like to refer to an author, Robert Kaplan, and his book, The History of Zero, Notes on Almost Nothing, where he actually speaks that in ancient Greece, arithmetic was much more spatial activity, and sometimes also called logistics. So my take on arithmetic, perhaps in this talk, will be more about kind of arrangement of thought and arrangement of architectural processes. So, and we'll see how it goes with the discrete and the continuous that has been addressed earlier in different talks today. So certainly one can think of mathematics as something very coherent and well arranged. And perhaps there have been similar attempts in architecture, at least in history. But nowadays, I guess we're living in a world of multiplicity for a long time already, with the help of digital technologies. And I'm not, going to go back to the historic examples here, but this is just a kind of intro towards that direction. So what I'd like to begin with is notion of an idea. My research here during the 2 years of PhD has been focused on the issue of conveying architectural thought or architectural idea, not just to the architects and engineers involved in the project process, but also beyond that, to a more general audience. And in many cases, one can think of ideas, at least in human history, that tend to get idealized. They become fixed to a certain degree. This is not my intent. While I'm doing this research with a topic of compression of thought in architecture, I'm thinking it in a somewhat broader terms, let's say. And here I'm referring back to Leibniz, the German philosopher, mathematician, kind of man of multiple talents. And he, in his kind of text on Introduction to Metaphysics, actually made a distinction between ideas and concept. I'm not going to go too deep into that. In my mind, actually, this refers to what he later in his career as a summary wrote in Monadology. He was asked actually by others to sum up his philosophy close to his end of his life. And in Monadology, he speaks about substance, a monad, that is at the same time indivisible, yet contains information about the entire universe. Metaphysical, but my take maybe is more related to the practice of architecture in it. So in my mind, concept is something different than idea, and one should mix them, but it's not the same thing. Concept is something much more in motion maybe, and in contact with different other ideas. So a small example, arbitrary points, the results of, let's say, temperature sensors in a computer, interpreted as a kind of 3D space as coordinates, arbitrary points that start to approximate the cube. Maybe it's not so important what it does, but actually the way I actually want to proceed from this it's an attempt to reach maybe somewhat the fuzzier beginnings of architectural thoughts, at least in my own experience, and then go on and try to clarify it. So one could clarify it by just connecting these dots, these points in space, with a continuous line, uninterrupted basically, just these kinks at the turning points. And the connection happens in the order of the appearance of these points. Again, it's not random, it's already starting to approximate something that might start to look architectural. And then, if we compress that thing mathematically in this case, but also one could think it's a conceptual endeavor. And I've done it through calculating a cubic root of each of these coordinates. And it becomes this small dot, but when we zoom in, it's again something similar, yet already starting to define a bit more what it's about. It's actually approaching the vertices of the cube and leaving the space or emptiness between them. Again, a similar approach, as I described earlier, one continuous line connecting all these dots in the order of appearance. I also kind of kiddingly call this algorithmic sketching because it's not done by hand, it's just these simple algorithms that do this. And make perhaps even more material looking structure in the end. One can also take a different approach. In this case, it's the technology, the manufacturing technology of 3D printing, the very PLA material itself, the temperatures in the environment, and the guideline that results in this kind of cube that's not fully a cube, it's kind of shifted. It's in some sense more continuous than maybe the previous examples, but yet it's still a little bit arbitrary as well, because usually when one thinks of 3D printing, one wants to have the exact results that one has as a toolpath in a computer. So these connections to materiality, thought to materiality, and these transitions have been of interest. And perhaps 5 years ago, we started in 3DL to experiment with 3D printing clay. And of course, this is a kind of first generation of those results. And we were brave enough, let's say, with Martin Pettersson to make a public display of it during the Science Day at Mektori. And what I've told about these kind of first shots, these objects don't exist anymore. They went into recycled matter, let's say. But what I've told some years ago to my students is that, okay, I don't want to be, I don't want to brag or anything, but in my mind, at least to a certain degree, these objects compress or bring together 6,000 years of architectural history in this very simple form. Take it as a joke if you want to. And then, of course, we went on, and we started to realize through these investigations into the digital, into the toolpath, about making these continuous lines, that this connection or meeting points between the thought and matter can be quite fulfilling, even if they don't look like that in the beginning. So some maybe 4 years ago, or even more, we started with material upcycling. We've done this in collaboration with the ceramics department of our school, which is not part of the Faculty of Architecture, but Faculty of Design. And what you can see here on this slide is the very ingest system of this 3D printing machine. And in a funny way, this clay, this kind of almost mythical material, comes back to the kind of, let's say, primordial substances, and in some ways can be thought of as a beginning of one's investigations in matter as well. But when it goes through the digital transformations through the robotic arm, of course, some other sometimes more conventional, sometimes more unexpected results start to emerge. And what was interesting about this particular experiment was that I first thought of it as, okay, I have this leftover clay in the ingest system. It's basically kind of very basic form of clay, and with my thought, with these trajectories, algorithmic endeavors, I kind of structure it. But looking more closely at the results, it became apparent that there's something more. Besides the matter, there's also texture of the matter, of course, but also facture, the kind of result of the, let's say, in some sense, the intersection of technology and its marks on the matter. And what I learned a little bit later was that it wasn't actually the kind of purest form of clay that I was recycling there, but actually it was partly, at least, a result of one master's student's, let's say, author's material. And she had mixed rock wool or kind of fibers into it, and that's why it reached the results that it did. Of course, that wasn't the only cause of these patterns that appeared on the surface, but it nevertheless, at least in this case, was one of the more significant results and more unexpected results. Of course, one can find all sorts of tectonic references in there because of gravity, matter interacting, but one can also look at this as a kind of mixture of this discrete and continuous, because all the tool paths originally were straight lines because of the kind of let's say, development stage of the machinery and algorithms. At that point, it was necessary to have as simple as possible the toolpath, and all these round corners here are the results of later interferences by the algorithms more connected to the robot. Actually, in this case, it's also the result of the work of Kaiko Kivi's middleware. Some photos of these results. Of course, it's not so perfect in the beginning. Lauri Kilusk from the ceramics department actually wanted to quit many times during these printouts because for him these were too imperfect. For me, they brought new ideas, new references perhaps to these very puristic initial forms that I had designed with algorithms. Maybe I should mention that all these toolpaths were designed, at least in the beginning, with a very kind of hands-off way. I wrote a small piece of code in a specific iterative software. Maybe some of you have heard of it. It's called Linnemaja system. I've used it for more than 20 years now, but I'm not focused only on that. So there's another example here that I did as an introduction during a short workshop that I taught at Bezalel in Jerusalem, in Israel, some 3 years ago, I think. And of course, they had a very different machine, but it also had some, let's say, glitches that seemed interesting. At least to the one who helped me, a ceramic artist, Noam Klumek. So maybe as a kind of midpoint here during this presentation, I want to address Leibniz once more, but this time through meta-mathematician Gregory Chaitin. So somewhere in the early 60s, you know, when the digital computers were emerging, they were big machines, he was already philosophizing about the impact of these machines, and already then, I think maybe he realized later, but then he was kind of taking the, let's say, Leibnizian path in some ways, having the kind of very simple beginning and through computation reaching more complex results. And this is actually a direct quote from his booklet that he published after a winter school in Estonia some 16 years ago, I think. So his idea has been about that compression is an initial and the primary mode of understanding things. And of course, his take is through the eyes of mathematician and the computer scientist, since he has worked for several decades, I think, at the IBM Watson Institute, and published also quite substantial literature on these ideas. So again, my own take on this compression of ideas looks quite simple, and it's based even on a more simple code, just maybe 10 characters. These are projections of these results. Again, a little bit cuboid, but also addressing some other architectural agendas in my mind, at least, because it's at the same time both a wall, a vault, and a cantilever, and it also has an opening somewhere in there. And having been treated by the same algorithms that I showed in the beginning with arbitrary points, it starts to make perhaps even more, let's say, Renaissance results in some parts at least. So these largely have been kind of more experimental works that I've shown here, but I've also, as Andres mentioned, practicing as an architect. And I haven't kept these technologies off from that practice, although it's of course very different when one starts to implement them. And this is quite a kind of a project that has taken a long time. We started it with Martin Auninen and Ingmar Melioranski in 2005. And this small few lines of code here in the left-hand corner, let's say, of the image, actually defines the movement of this line, and this line defines the balcony system around the cuboid towers that now actually, after all these years, have been built. And maybe the reason why I'm showing this here during this presentation is because I guess there has been a lot of, you know, discussions and articles about how to proceed and convey digital information within the system without a loss, or, you know, how to convey it without, you know, it being kind of vanished from there in the end. And how people actually do a lot of extra work during this process in spite of the fact that maybe digital technologies could be more straightforward, at least in some mind, towards the end goals. But my take actually is more addressing the fact that perhaps even more important than this kind of lossless digital transformations, it's about communication between different parties in the project design process. Of course, besides the architects, also structural engineers, most importantly the client, and many other kind kind of organizational structures like the city planning office and so on and so forth. Part of the reason why this took so long time was that it actually was on a site that was formerly occupied by really small-scale private houses, and there had to be a detailed planning process that had to go through. So here, at least, you can see the kind of overlapped imagery or models of the LiDAR scanner last 2 years from the Estonian land board database and my model from 2010-2011. But it wasn't this model, and since then I actually kind of left the project, and it took the other architects and engineers who actually realized it. But the question is, can an architect design an algorithm that actually reaches the end result built space? In this case, it was quite complex, many changes, not only because of the kind of, let's say, local conditions, but also the relative vicinity of the Tallinn airport. So initially these towers were both a bit higher, a bit more slender, and of the same height, but here you can see that perhaps the trajectory of the plane that we were given has influenced the result. But also what you can see here is how pretty much the information, of course with extra measurements and detailing, reached the engineers, because at least in my experience so far, many of the Estonian structural engineers tend to, in a way at least in terms of the 3D model, start from scratch. So they build their own models because they think that they have better control over the precision and other aspects of the design. I have some kind of imagery here about the communication with the engineers. Here, Eero Tuhkanen, who is now actually supporting the PAK, in 2007 already made the initial calculations for these towers. And of course, architects can think what are the kind of structural aspects of problematic aspects of the design, but engineers have their own experiences and knowledge. And besides the kind of usual high-rise problems, in this case also the kind of pressure from the groundwater was an issue, because it's situated on a limestone plateau that has this occasional streams of water pressuring from the Ülemiste lake. But there are other examples here about the communication between, in this case, Martin Aunin and the structural and design engineers of E-beton element. And again, you can see that the communication actually, in this case, was not through a kind of direct sharing of the model or the BIM, the kind of magic BIM that has been the buzzword in architecture, at least partially during the last 10 or more years, but it was just the screenshots sent by email and questions formed around these problematic places. I had a chance of seeing these elements being made in the factory during the Commandant exhibition, and it was quite revealing in some parts how things actually get made, how we, or I at least as an architect, always don't think about the complexities. I think about some of them, but not all of them during the actual building process of the elements. Of course, in this case, as you can realize, it's largely off-site prefabrication brought to the site with trucks and then lifted up by cranes. But many things had to be addressed. For example, the engineers told me that they had to buy a new machine to, let's say, flip these balcony elements after they had been poured and had cured into a kind of solid state. Of course, structurally, there are many issues here, but I think they've been resolved quite well during this process. And also what these engineers usually do is they, maybe they even don't communicate this all the time to architect. Architect has to ask the right questions to get this knowledge. They actually also think about the process and the balances during lifting up these elements and how the construction workers on site actually sometimes have to align these elements quite precisely there. They cannot, they're so heavy, they cannot kind of tilt them manually up there on the, I don't know, 14th floor. It has to be pre-calculated. And sometimes some of the elements have to be tilted in order to put the first edge there and then lift it to a vertical position. So the question for me during this process, and during my research, I'll go on investigating these kind of real-world projects, has been also about how to not just leave room for other thoughts, for other people's thoughts, my own thoughts, other architects' thoughts, but also how to engage these people, because even if they're quite rational people, like structural engineers tend to be, one also has to engage them somehow. They have to be thrilled about these projects. And what I learned yesterday talking to some of the engineers was that they actually maybe even didn't realize how repetitive this structure was in the beginning, at least in the design. So it could have saved them a lot of extra work during the design of these elements, actually the part design and calculations, if they would have known it. And what they realized also, and what I haven't kind of spoken out loudly, is that when I designed these with the other architects, with Aunin and Ingmar Melioranski, I thought about actually my own experiences as an architect. You see, I was actually living in New York when 9/11 happened, so I thought about how would I address the ground condition with the limitations that I had been given. How do I build a continuous, more or less continuous loop between the ground and the upper floors? Of course, it's not the, let's say, NURBS-based continuous design that I had done earlier while in New York, but it's actually through this orthogonality, through this discreteness, addressing the same questions, albeit it might not be that visible when I don't mention it. This software, or this platform, has been mentioned today already, and I'll show my short or brief experience with it as well. So in some ways, I think of it, at least based on the experience that I've tried to convey here today, I think of it as a kind of quite strict textual description, almost a command line that I give this system. And in this case, I described it as a kind of Corbusian architecture meets parametric design in 21st century Sahara Desert borderlining an ocean. So quite figurative. It's not this kind of single characters, relationships between them, or numbers, but quite a literal description of what I want to achieve. And first, of course, as it's a kind of combinatorial system based on what is already known, what the system has been geared towards, it's combining these thoughts these descriptions. And you can see that first the Sahara or the desert landscape started to emerge, and gradually it became more architectural, perhaps. And in the system, there's an opportunity to select or refine or combine these operations, and one can go on then and maybe receive the result that one perhaps vaguely but still has imagined in the beginning while describing it. Or if one doesn't like it, one can start again, maybe refining the command, the description, or selecting a different image. So as you can see, it's an image-based system. It's not a kind of full architectural 3D model that one receives from this system. But still, at least I'd like to think that my prior experience with similar systems, and this generative system, by the way, is called sometimes artificial life system. And nowadays, it used to be that artificial life was kind of the bottom-up opposite of artificial intelligence, which was thought of as a top-down activity. Some people in the 60s and 70s, Marvin Minsky and others, were trying to come up and implement a system that is completely ex nihilo in some ways, let's say. But yes, and then maybe this brief introduction, at least for me, with this Midjourney AI, wasn't the thing that took the most of the time. Most of the time took actually the process of gaining acceptance from the bot that was blocking the platform. And it's a kind of interesting story, maybe, at least for me. You know that usually when you're confronted with these portals, you have to make a selection, you know, choose a street light or a zebra or something else. In this case, at least for me, it seemed that as I knew already, I had read a few articles about it by an architect that I know, who works in US. And perhaps I thought of it a bit more than one should have. So when I was confronted with a question with these images, for example, choose all the smiling dogs, I literally chose the dogs that looked a bit like smiling, not just, you know, evaporating or, you know, breathing deeply, or, you know, cats with short hair or so on, or living rooms. You know, some of these images were so blurry that they looked like a kind of office corner, like the leisure corner in an office. So in the end, with this system, I got a kind of remark. You know, I was wondering why I won't get this SMS with the access code. And the system told me that there's something fishy about your answers. So maybe my answers were a little bit too nuanced. I was kind of, in some sense at least, overwhelming the system. So it, you know, in some ways it's these cognitive architectures that not just physical space, but these experiences with the new that change our thinking. And in some sense, I'm not perhaps so worried about this encounter with the AI, or even the more, let's say, edgy version of it, quantum AI. What I'm more concerned about is perhaps that they're usually black boxes. We don't know that much about their ingredients or how they operate. And sometimes even the people who have programmed them don't quite get it, what they're doing. But of course, it's an, you know, evolving part of science, and a lot of scientific articles are written on it. So perhaps some people know really well what they're doing. And as a final project, I'm just showing kind of a previous version that I did 11 years ago for the first tab and the exhibit. The bridge, Ingra Bridge, I called it, which is a result of a kind of searching for a new, let's say, with Roemer's words, a more gentle connection with the ground condition and the building. And it's these 5,050 elements that, through this very brief algorithm, again, the compressed architectural thought, the movement in space, that result in this structure, let's say. And yeah, I don't know, if you go to the tab exhibit, then perhaps this is still part of the permanent exhibit. I don't know, I haven't been there recently. So that's basically it. I don't know how I did with time, but maybe we have more time for questions now. Thank you.
Thank you. So thank you, Martin. Do we have questions from the audience? Many different projects. So one of the keywords I was thinking about was actually something that came up this morning, was this idea of hybridity. And I think your experience with these towers, like this, you know, hands-on experience with doing real stuff, brings to mind that you started off from this kind of sort of immaculate laboratory space where you conceive this pure mathematical architectural concept devoid of any kind of historical or social circumstances, and then kind of you encounter this kind of working process which actually combines different technologies, you know, not only the most cutting edge ones that we have, like in this small scale 3DLs, but really technologies that go back years. And then in a way, how do you see that? I mean, this, in a way, for me, it seems that it's somehow inevitable that we have this hybrid situation constantly, because the technology, like, you know, there are these laboratories where the technologies run like fast ahead, and then there's there are the building sites where you actually operate by something that has been mastered, you know, over decades, and where you have the labor that is capable of doing that. So do you have sort of like, how to say, how do you operate as an architect? Do you have to dumb down yourself, or do you enter dialogue, or what is your...
I guess, I'll speak here. I guess there's kind of many ways of answering it, but of course, as an architect, you know, for the last 27 years, I've gone through changes as well, hopefully kind of evolved, or at least in some parts kind of gone further. And perhaps, yeah, I can say that earlier in my career, I was more focused on the geometrical aspects, for example, and perhaps in some regard more puristic or idealized world view, how these things should be implemented, and how maybe an architect should have a kind of even more direct connection to the you know, the procedures that happen on site with these larger structures as well. But now I think more and more, so, and I'm older now, I think it's about the kind of human relationships, and it's of course these algorithms and new things still kind of trigger new thoughts and are of interest to me, but I think much more needs to be kind of gone through or thought about how these processes actually take place. Of course, also technically, but not so just like in that sense, but also how we communicate that thought that we have if we wanted to survive through all these process. And this case, the tower was a good example, because it actually, the code, let's say, is built now. And I wasn't involved for the last 11 years with that. So, yeah, I guess, I don't know if I answered your question.
I mean, what would be interesting maybe that that can we start from the messy reality right away? You know, how about acknowledging that the situation is hybrid? Because what was interesting, you know, like this historian's remark, is that you showed the order system, but this is this very specific image by Claude Perrault, where he actually revolutionizes the whole way how orders are presented, and he, you know, scales them up nicely. Whereas the messy reality, this is the moment where the messy reality of these historical orders that inherited from Rome was put aside, and then he sort of, you know, purified it. Already entered. We are entering this laboratory space at that moment. So in a way, is there a way to put this? You know, say that actually reality is messy. We're always dealing with hybrids. We're always dealing with, you know, parallel technologies, no matter how much we want to be, you know, part of this super.
Yeah, I think it's true. You're right, but you know, as an architect, one cannot really tell that to a client all the time or the other parties, because there's some kind of liability involved, and people don't want to take so many risks. Of course, there have been, at least maybe not so much in my case, but with other architects, there have been very experimental clients who are willing to kind of give the architect the space to kind of elaborate on the messiness and discover through the project. For example, very good example in my mind is the kind of what Jeffrey Kipnis summarized in the film that he kind of wrote the script for some, I don't know, let's say 18 years ago, called Constructive Madness. And it's about how Frank Gehry had a very wealthy client in Ohio that wanted a pool house, but that grew and grew, and Frank Gehry could kind of elaborate and go further with his experiments, this messiness that he has in his projects. And the building was actually never built, but you know, result is Bilbao, and maybe the kind of, you know, the signature work of Gehry that, you know, some people are critical of, but I still kind of value in some sense very highly.
So, do we have questions from the audience?
This is a very kind of ordinary situation for me after lectures. I don't know what I'm doing wrong.
So, if not, then we will.
My supervisor can tell me later on. Yuri.
Yeah. So let's thank Martin. Oh.
The human condition is. The human condition is it has been investigated in the courtrooms of USA that when you want to have the best verdict, you have to appear after lunch. And then the sentences are much less, so because the charges are fantastic after the lunch. So this is the case. You can pretend that here we are. And it actually is the question of statistics that comes to the big data. So we can manipulate the charges with these data. So it is probably the future of all kinds of processes that they can be modeled by AI. When Isaac Asimov was writing about Foundation, the fantastic series, he was talking about Harry Seldon, a mathematician who, it was called, if I remember correctly, psychohistory. He could predict everything that will be there. And I remember reading it and laughing myself that this will never happen. But now it is here. Cambridge Analytica has collected the bloody data and made it operational, made it dirty, as Andres just said. But I have no question, I'm sorry.
That's okay. I have an answer, though, to another question, maybe addressing a little bit this hybridization as well. I tried to kind of weave it into the mid-journey part of the lecture, but somewhere around maybe 12 or more years ago, I had a discussion with a kind of quite well-known Estonian, one of the founders of Skype in Tallinn. And he was very into this Ray Kurzweil and AI surpassing humanity. And of course, it's hard to, you know, argue with that kind of person. He's very rational. He has very good argumentations. But my maybe take and reply to him was that I think, and I hope also at the same time, that not just these AIs will evolve or develop further. Maybe evolve is too Darwinian. We as humans also, by interacting with these systems, can probably go further. Thank you.